Hi again. In this session, we'll continue our discussion on life tables and discrete life distribution as well. And one concept we will look at in discrete future lifetime is something called Curtate lifetime. Right? So the Curtate future lifetime. I mean, in simple way. If you ask anyone what is your age, like if I ask you what is your age, you would say my age is 20, right? If I ask you what's your age, you would say my age is 20. But usually you look for, like, when we say age 20, it's not necessarily age 20. It might be 20 years and 3 months, 4 months, 5 months, 6 days. So usually you say like you answer by the year that you completed. So you answer the largest integer, right? So when somebody would say that my life is 20 years old, we know that you have lived full 20 years and plus. So and this is the whole idea. We need to look at a function, the Curtate future life function. Let me use different color. So when we say Curtate future time random, if you look at the Curtate future time random variable, we will use k, big K of x, right? So if you answer I'm 20 years old, it means like maybe 20, 21, 22, 23, right? So when, or let's take the general one, k. And this is similar to tx, but this is k to say it's Curtate. So it means that if somebody answer like what was the future, like how many years the future, like for somebody's age x today, and we'd say the death occurs in k Curtate, it means that x plus k and somewhere between and x plus k plus 1. Right? Death occurs somewhere here. So if k, then we know that death. So if somebody, again, like if we see that the future lifetime random variable, the Curtate future lifetime random variable is k, it means that death occurs between two numbers, right? X, small x, the age, plus k plus 1, plus k, and x plus k, actually there is no equality here, x plus k plus 1, right? And this is why it's important to try to understand, try to use some examples related to this, because usually when somebody reports the age of death is 79, it might be 79 and 3 months, 2 days. So it's important, to look at those fractional ages. So if you would if you take, let's say, what's the probability? We always be interested in the probability of mortality or death occurs at k. We know that this is equal to probability of death happens between x plus k and, as I mentioned above, x plus k plus 1, right? And if you try to look at this one and we use a notation of lx plus k, so like the death occurs here, it means, well, let's draw it. As I mentioned, you have x, we evaluating at time x, for death occurs between these years. So what's the probability of this to happen here? This one can be written again, as I mentioned, pk x equal to k can be, which is here, can be written, this probability can, if you take, we are interested death here, so you take lx plus k and lx plus k plus 1, and since we evaluating at this time, then we need to divide by lx, right? As always, this is the same logic. You divide by lx, but you see who survived here, lx plus k. You subtract from it who survived x plus k plus 1, lx plus k plus 1. So you take the depth here, which is this depth here, and you divide it by, because we're evaluating here, you divide it by the cohort you start at Lx. This one you can also, you know, if you take this term, this can be simple, right? It's k for like surviving, for person to survive px and survive to k years. You subtract of it for the probability for x to survive, not k but k plus 1, right? It's the same, just this minus this, right? And this one, right? So this is like a review of what we did in the past, really nothing new here. But same logic here, you can think about it. You are here, so to calculate this probability, so first you need to survive to here and death occurs here. So the first probability, you can write it also, is to survive k years px and death multiplied, because independence we multiply, and death occurs in this period. So it's a qx plus k 1 year, qx plus k within 1 year. Right. This is another way you can look at it, right? So multiple ways you can look at it. But if you remember, this is the definition also of the it's the same one. It's the definition of the deferred probability. So you are here, right? So you have deferred mortality to here. So the deferred period is k. So you have k deferred period, and now q x. We don't usually write the 1, right? We don't usually write the 1. So all of these are the same thing, you know, probability of k equal k. Probability, the random variable, of the largest integer, the probability for it to be a number is this is the probability, because it can occur between any of the two periods, right? That's something we need to keep in our mind. It's not something that I would memorize. I mean, I should know them if I get a question, but usually it's logical. Those, you know, like the things that if you understand it, it comes naturally. You don't need to do much of work related to this. Another concept related to this is the future, so now the future lifetime, you know, the expected value of the future lifetime. Let's recall what we did. We remember in continuous distribution, we said x 0, and this is the expected future lifetime. But this one, this 0 here, it's to say it's continuous. When we looked at uniform distribution, exponential, all those, those are continuous distribution. But in our case now, we're dealing with discrete distribution. So same thing we use, but now instead of ex, you know, the expected life at age x, maybe at age 70, but we don't have, it's not continuous. So without the O on to the right corner on top, without this O, then we understand that this is discrete, right? And remember, what is this? It's the future lifetime, the expected value of the future lifetime, right? So you can write it, you know, like the expected value of future lifetime, right? And if you remember how we calculated the expected future lifetime in continuous case, is we said we integrate tpx dt. Right? Here it's discrete. You know, in discrete you sum. Instead of tpx, we don't have tpx. We'll sum. I'll write it, you know, the formula, and I'll tell you how we compute it. But let's write the formula. Px, but instead of k, we add k plus 1. We'll come back to it. And when you start your k, you start from k equals 0 here, right? So you sum. We'll come back to how we compute it, right? We'll come back to it. What if you wanted to find the expected kx to 2? the second moment. So we can calculate the we can't use it to calculate the variance. This one, not the variance, it's the second moment. Just know the formula now, and we will tell you how. I'll tell you in a second how with example how to compute it, right? If same one, k plus 1 px. So this is multiplication. You multiply 2k plus 1 multiplied by the same probability here. Right? Those really need to know them. Another thing I wanted to say, what's the relationship between the continuous and the discrete, the expected value? If you want another relationship, just to keep it handy, if you have ex, the continuous, and you want it to compute, and you have usually the discrete, right? The discrete. And usually you add to the discrete 1/2. And this is assuming UDD, uniform distribution of death, right? So this one also another relationship to memorize it. We talk lots of, let's take one example. We talk lots of definitions now. Let's take one example on this one. Let's take example here. Simple example. Let's make it simple. We have x. What is x? Is age, right? X is age. X is, let's say, 96, 97, 98, 99, 100, right? So we follow a cohort. And this is LX. So 96, we follow a cohort. They started with 180, then 130, so there are 50 deaths, and then we went to 73, and then we went to 31, and by age 100 all of them are dead, right? And the question, what's the question here? The question is to ask us find E96. So wanted to find the expected, what is E96? The expected life expectancy, or the expected remaining lifetime at age 96. At age 96, what's the expected remaining lifetime, right? At age 96 based on this mortality table. So the first one, and then we wanted to ask also, the question is ask variance of K96. So let's see, I instead of memorizing the formula, just, even if it's not given to you in table, it might be given to you in a line, it might be given to you in many other ways. It might be given to you PX, QX. You can always go back and forth between LX and the probability. Let's go from LX to the probability, because the formula here, it asks us the K plus 1, the PX, the probability. First thing, let's define what is our K. So if we are, the year we are interested in is starting here, because remember the question wanted to find E96. So the first year I would usually have K equals 0. Let me use same color, or maybe black. Say 0, right? The first year is 0, then 1, 2, 3, 4, right? So it's very important to get the K right. After the K is, you need now K plus 1 P96, right? So K plus 1, it's 0 P96. Oh, sorry, not 0. 0 plus 1, it's 1. And this will be L97 divided by L96. 130 30 divided by 180, right? This divided by this, right? It's simple. Then now k plus 1, now your k is 1 plus 1, 2. It's 2p96, right? And this will be L98 now divided by L96, because the same denominator 180. But what is L98, right? We go L98 is 73, right? It's simple, right? It's so easy. Now what is the next one? K plus 1 will be 2 plus 1 is 3, P96 equal L99 divided by L96, correct? So this one will be L91 is 31 divided by 180. Well, I mean, here is the thing about it. This will be 0, this will be 0, so we don't worry about it. Let's go to the question. What's the question? The question asks us E96. E96 equals sum k plus 1 px. And we said we start from k equals 0, right? Which we already did it. So all we need to do is to sum up these guys. Right? Because this is what we wanted, right? So you sum up these guys. Let's sum them up. So 130 plus 73, 203, plus 33, 31, 234, right? So this one will be 234 divided by 180. Let's do the math. 234 divided by 180 is 1.3. What does that mean? For a life at age 96, it's expected that this life will have 1.3 years of remaining lifetime. So at age 96, the life expectancy for somebody who reached that age is 1.3 years. And usually, in also very important aspect in actuarial mathematics or in risk management in general, that we need the variance. You know, when you compute your product, you take account measure of riskness, and it usually takes standard deviation. So the variance is very important, right? So the variance for this, it's given to us by here, by the definition 2k plus 1 multiplied by the same probability. So the easiest way I will do is, now let's keep this, this is 1. I will add 2k plus 1 and then multiply it with that one. So 2k plus 1, if you have k is 0, 2 times 0, let me write it here, 2, 0 plus 1 is equal to 1. Right? Then the next one, you have 2 times 1, 2 plus 1 is 3. And then 2, 4, 5, 7, 9. Let me just use lines so we don't confuse ourselves. So now the second question was to ask us to find variance of this one. And this one, immediately we can write it. Summation 2k plus 1 multiplied by k plus 1 p96. Right? Here p I mean 96, right? So now we take 1 multiply 138, 1 multiply 130 over 180, then plus 3 multiplied by we go back 3 multiplied by 73 over 180, 73 180 plus 5 multiplied by, forgot what we have, 31 over 180 plus 0. Just to use the calculator, 130 plus, oh sorry, 3 plus 5 times 31 divided by, so I got 504 divided by 1. I made a mistake, I'll tell you what it is. 2.8. I made one little mistake here. Yeah, this is mistake here, sorry. Now this is, we want to find the variance. Just a mistake. In order for us to find the variance, we need first to find K22. The expected K22 of x equals 96. This is the second moment, not the variance, the second moment, right? So what we calculated here is the second moment, right? Let's go back to the relationship. This is the second moment, right? So this is the second moment is equal to 2.8. So now remember, E0, we got it, the expected value to be 1.3. Now the expected of Kx to 2 of 96 is equal to, I just computed it, it's 2.8. 2.8. Now we can calculate the variance, right? Now variance of K of the life 96 is 2.8 minus 1.322, which is, let's take 1.3, raise it to 2, and 2.8 minus it, I got 1.11. So the variance is 1.11, right? It's easy. Let me go back. Very important, you know, to this is my view. Very important for you to remember this table, right? This table. So if you're given question, like let's summarize how you do it. You have x, this is the age, then you have lx, maybe px. You might be given x or px, k plus 1, but you can move from one to another, right? And also you can also sorry, maybe you start with x, you add k, you define what is k, start with 0, and then if you sum this up, this will give you e. And now you add 2k plus 1. So if you give this column 1, column 2, column 3, column 4, column 5, right? So E is summation of column 4. Now expected second moment of K2 is summation of column 5 multiplied by column 4, right? And it's very simple, very simple. It's not any difficult. All right, I think this one is we done for this session. We'll add another session and then we finish this module on discrete and life tables. All right, see you later.